Let's look at this question. A coding machine takes strings of words as input and gives the output as code consisting only numbers. The sentence, quick brown fox jumps over the unsteady dog, not the lazy dog. Unsteady dog is coded as 1106163543290 485 449 so on and so forth, in that order. However, the digits within a word are coded in a random order. So it is not like T is directly corresponding to 1 or H is directly corresponding to 1. That is not. The following information, additional information is not. The coding pattern is case sensitive, does not distinguish between uppercase and lowercase, and each letter of the alphabet series has a code which is a single digit from among 0 to 9. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. A digit may be a code for either 2 or 3 letters. So given there are 26 letters, and each letter can have up to 3, each digit can have up to 3. So we will have something into 3 plus something into 2. Adds up to 26. So we will have 10 of these, no? So 6 will have 3 and 4 will have 2. 6 will have 3 and 4 will have 2, but we don't know. Okay. Next, 2 vowels cannot have the same digit as codes. Okay, so vowels are present uniquely. Vowels are special. Adjacent letters in the alphabetical series cannot have the same codes. Okay, so if B has a code of, let's say, 4, C cannot have the code as 4, C cannot have the, or A cannot have the code as 4. Okay, the sum of codes of all the letters of the word coding is 16. Okay, sum of letters of all the words of coding is 16. This is also. Okay. So let's try to make sense of the statement. The way we do it is we write down the word, the quick brown fox jumps over the unsteady dog. Unsteady dog. And the code is given as 1106165439290. Fox is 485. Jumps is 23950. Over is 4419. The is coded as 011. Unsteady is coded as 30403171. And dog is coded as 424. So we have to write this down. This is not nice. This should be 5. Okay. We have to write this all down because the recording would be, as soon as I identify, I can allocate a particular letter to a particular number, I will write it down in my table. We can have 3 spots for every digit. Okay. Looking at, and you have to now be agile. I'm looking at, see, over and these two. I know letter E is common. And the only digit that is common is 1. Which means E has to be digit 1. As soon as we identify that, Our next check has to be remove E, remove 1. Everywhere you see an E, remove a 1. Everywhere you see an E, remove a 1. Everywhere you see an E, remove a 1. Our next work has to be okay. I see over and dog or over and fox, whatever you choose to see. Can you see OVER 449 and FOX 485? The number that is common and the letter that is common is O. So O has to be 4. So I can get rid of O, 4, O, 4, O, 4, and O and 4. This is also gone. Okay. The next letter I see is D from dog and unsteady. From dog and unsteady. D is present here, D is present here. And only digit 4 coincides. So D has to be 4 also. D has to be 4 also. Okay. Now look at brown and over. Look at brown and over. The digits left are V and R. Sorry, the digits left are 4 and 9. And the digits left are 3290. R is the common letter, 9 is the common digit. So 9 has to be R. 9 has to be R. And as soon as we identify that, okay, we also know V has to be 4. So all the three letters for 4 are identified and the word OVR is done. The quick brown fox jumps over the unsteady dog. Okay. Okay. Also for G has to be the digit 2. G has to be the digit 2. Okay. Next thing I see. Which one can I go? Now for S, I am seeing for unsteady S and S 23950 and 3000317. The only common digit is 0 and the only common letter is S. So S has to be 0. S is gone, 0 is gone, S is gone, 0 is gone. Okay, this is also uniquely identified. Anywhere else do we have an S? No. Fine. Now A, unsteady A. A can be 3. I'm looking at unsteady A. A can be 3. A can be 0. A can be 3. A can't be 1. A can't be 1. Because we were told that two vowels cannot have the same digit as their code. So because E is already 1, A can't be 1. Okay. Ah, fun thing. This is now interesting. Look at TH and 0, 1. T has to be either 0 or T has to be 1. T cannot be 0. T cannot be 0 because S is already 0 and S and T are adjacent letters. So T cannot be 0. So H has to be 0. T has to be 1. This is gone. And T and 1 is gone. Tn1 is gone. Tn1 is gone. Hn0 is gone. Is there any other H? No. Okay. This is identified. So right now I have SHETGODV identified. Yeah. So I'm going ahead. I'm going ahead and writing down, as in erasing all the letters and numbers that are already identified. Of course, so in an ideal situation, if I was doing it in a notebook, I will rewrite all the stuff down. But here I'm just erasing stuff. Over has nothing more, no more value to give me. The has no more value to give me. And dog has no more value to give me. STE gone. D gone. One gone. One gone. This gone. Okay. This is gone and this is gone. Okay. Now I'm looking at, okay, this, why this helps is visually now see, this enables me to compare stuff even better. BWN and UNAY, N is common, N is common, and you have 3 and 0 common. So you could have N at 3 also, you could have N at 0 also. So that is not great, can't really do that. A can also be at 3, everything can be at 3. So the only thing left for me to work on, is this coding. Right now, for O, I know it is 4. For D, I know it is 4. For I don't know. For N, I know it is 0 or 3. For G, I know it is 2. These letters are already known. These letters are already known. Okay. Now for I'm looking at the pairings that can exist for I. It can be 6, possibly 6. Can it be 1? No, E is already eating that up. I can be 6. I can be 3. I can be 3. And I can be 5. C. Okay. How do I break this down? C. Can it be 6? Possibly. Can it be 1? Possibly. Uh, break this down. Mm. Oh, fun. I haven't really used this. Look at U. It is present in jump and it is present in unsteady. It is 3 here and 3 here. 2395 3037. So U has to be 3. U has to be 3. So I've got U3 and U3. This also identified, which further enables me to remove 3 as a possibility for I. Okay. U3 further remove the possibility as I. Now, 6 or 5. I have, oh, 3 vowels are already accounted for. This is a vowel, special number. This is a vowel, special number. This is a vowel. So there are 2 more vowels left, A and I. I can be 6. A cannot be 6. A, can it be 0? Possibly. Can A be 3? A cannot be 3. A cannot be 3. A can be 7. I'm left with a lot of A has to be 0 or 7. I know A has to be 0 or 7. And I has to be 6 or 5. Now for C, I'm just looking for C. Can it be 1? Yes. Can it be 6? Yes. Can it be 3? Yes. Can it be 5? Yes. I don't know, man. 1 is... I'm looking at 10 is already made up. 10 is already done. Now see from this, from 4, 4 and 2, 10 is already done. If I turns to, if I is 6, if I take I as 6, 4, 4, 2, it would mean N also has to be 0, C also has to be 0. Given that for O and D, 4 and 4 is already identified. If I take G as 2, if I see, this is guaranteed, and this is guaranteed. I has to be either 6 or 5. It cannot be 3 because U is occupying 3. So if I is already 6, C and N both have to be 0. We know there is only one extra spot left in 0. We know there is only one extra spot left in 0. Additionally, C cannot take a value of 0 at all. C does not have the capacity to take a value of 0 because in the code there is no 0 available. Which should mean I taking on the value of 6 is impossible. I has to necessarily be 5. I has to necessarily be 5. And given that I has to necessarily be 5, now see 4, 4, 5, 2. N had to be 0 or 3. N had to be 0 or 3. If N takes a value of 3 now, if N takes a value of 3 now, if N takes a value of 3 now, I will exceed 16. I know the summation had to add up to 16 only. So N cannot take a value of 3. N has to be 0. 7 and 8, 15 is already there. So C has to be 1. This also gives me wonderful information. N is definitely here. C is definitely here. I is definitely 5. I is definitely 5. So I is 5. C is 1. And I is 5. C is 1. Okay. N is 0. N is 0. This is also known. Now A. A has 2 possibilities only. A can either be 3 or A can be 7. From here, A can either be 3 or A can be 7. A cannot be 3 because U is already 3. 2 vowels can't be at the same spot. So A is at 7. A is at 7, which leaves Y at 3. Y is here. This is also done. Again, I'm cleaning house. These I'm getting rid of. These I'm getting rid of. This I'm getting rid of. This goes away, this goes away, and this goes away. Is there a letter? Oh, U I already know to be 3, no? If I know U is 3, then Q and K will be 6 and 6. This will make my life so much easier. Q is here, K is here. This word is also entirely gone. This here is also entirely gone. So now I have B and W at 2 and 3. I have J and P at 2, 9, 5. I have F and X at, okay, I can go F and X at 8 or 5. F or X, F or X here, and F or X here. They can switch, and B and W. B and W, and J and P is at 295. So either J or M or P, and J or M or P, and 9, or J or M or P. This is also known. Remember, right at the beginning, we had known there would be 6 spots, that there will be 8 spots, or wait, sorry, 6 digits will have 3 codes each, and 4 digits will have 2 codes each, so that we reach a total of 26. The ones that have 3 codes each, the digits that have 3 codes each, I'm marking that with a rectangle of sorts. So this is that, 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 and this is that. These are the 6 digits that have 3 codes each. So 6 is supposed to have 2 codes. We've already identified. 9 is supposed to have 2 codes. One of the 2 codes is already identified. The only 2 letters that have not been mentioned at all are L and Z. Everything else remains here. So either L or Z, Z or L. Okay. And this seems to be the entirety of the sample space that we can potentially be working with. One more thing, one more wonderful thing. I'm just checking over and over again. See, S has the 2 neighbors as R and T. So either of these are there. H has 2 neighbors as F and G. Neither of them are here. N has neighbors as M and O. Neither of them are here. ETC, fairly far apart, no problem. G has 2 neighbors as F and H. Neither of them are here. B has 2 neighbors as A and C. Neither of them are here. W has 2 neighbors as W and X, and V and W. V and X. V and X. Neither of them are here. J has 2 neighbors, whatever. If you keep on going, see, for the ones that are fixed, it is not really a challenge. The challenge is for digit 5. Look at I. The 2 neighbors that it has, the 2 neighbors that letter I has are K and J, which is to say, J cannot be letter 5. J cannot be letter 5. But the rest can be there. So for J, there are only 2 spots left, 2 and 9. For M and P, there are 3 potential spots. Let's get to individual questions. What best can be said about the code for letter J? And that is why additional attention was paid to J. It can be the number 2 or it can be the number 9. So option C. Next, for how many letters can unique codes be identified? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. There are 17 letters for which unique codes can be identified. You could also have done it in reverse. BW 2, JMP 5. BW and GMP 5, 5 and FX 7. For these 7 letters, unique, FX and LZ or ZL. For these 9 letters, unique code cannot be identified. So for how many letters can unique code be identified? It has to be 17. Okay. If the code of the word topaz is, if the code of the word topaz is 41278, okay, then which of the following can be the code for jump? Let's work our magic. I know T is definitely 1, so this does not help. O is definitely 4, so this does not help. P is either 2 or 5 or 9. So P has to be 2 now. If P is 2, then M has to be here and J has to be here. P, M and J, they have unique spots identified. P is 2. Now A is definitely 7 and Z is 8 now. So if Z is 8, Z is 8, so L is 7. This is identified. Now they've asked me to come up with a code for Jammu. So Jammu will have 2 5s, 1 7, 1 3, and 1 9. 9 7 5 5 3. 9 7 5 5 3. This can be a code. 9 9 2 9s. I don't know. I need 2 5s. No 2 5s. No 2 5s. This has to be the answer. The letters, the digits that you finally get unscrambled. Can get unscrambled, but then the letter that has to be repeated is, or the digit that has to be repeated is 5. Next, if the code for the word topaz is 41278, which is the same thing, which set of letters cannot be, then which set of letters cannot be coded with the same digit? PGW. PGW is possible. They can be coded with the same digit. UYB. UYB can be coded with the same digit. IMF. IMF, you can have digit 5 replacing all these 3. IPX. IPX is no longer possible because I is definitely 5 and P is definitely 2. So the answer to this question has to be option D. And that is the entirety of this set. The beauty of this set is this is a coding decoding question which is typically reserved as a non-CAT question or a non-CAT topic. But then the testing that happens here happens in the form of for CAT, and then it is a very long drawn process. It is highly unlikely that somebody would be able to solve something of this nature in an actual exam hall because of the length of time it requires to solve this all. But then there is a good learning set. That will be all.